Hey Nishan, thanks for logging on. I can see you here. Do you have any questions that you want us to go over? So I'll just need to know which assignment you're looking at and then what question you would like for us to do. And I hope things are going well. I hope you're doing well. All of those things. Day 11 questions. Perfect. Okay, so it'll take me just a minute to get day 11 up here. I'm assuming that we'll do the practice questions at the end, the ones that I didn't go over in the video. So those are the ones I'm going to add to this screen. It'll take me just a moment to do that, and then we can get started. So if you can just type in the chat if there's something that I miss or if you're still confused about something. The great part about this question is that it's broken down into A, B, C, like there are sections, right? So you can ask any questions about a specific section. And I'll try to color code as well so that you can really follow along if you need to. So let's just read through the question first. So a robot now moves around an empty 100-foot by 100-foot storage room at a constant speed. So what this means is that it's always going at the same pace. It's not getting faster or slower. If the robot crosses 1010, which is a point in the room, right? That's a location in the room at 1 second, and 3030 at 6 seconds, let's plot the points. All right, so let's try plotting those. I am getting some error messages from YouTube, so I'm just going to check in and make sure that the stream is running smoothly. Nishan, if you notice that like something weird is happening with this stream and you can't see what's going on, just let me know, and I will do my best to fix it. See here. It's not listing on. This is strange. Okay. So it looks like something strange is happening. Ah, goodness. This is a mess. Okay. Oh. Now it seems to... Well, it's coming up sometimes. Oh, I guess... Okay. I pulled it up on my phone and we seem to be okay at the moment. So like I said, Nishan, if something weird happens, just let me know and I'll do my best to fix it. You've been through this before. You know that sometimes this can crumble. All right. So if the robot crosses 1010 at 1 second and 3030 at 6 seconds, first it wants us to plot the points and draw the segment that's connecting the points. So this is probably the easiest part of this question. All we have to do is make a graph and plot the points. Now, if you're doing this on the computer, let's say, and you can't draw, that's okay. I'm not going to take off points if you have to skip this one because you're on the computer, but you definitely want to draw these on a piece of paper for you to reference so that you can see what's going on. Okay, so here, if this is my graph, now let's make my room, right? So if this is where 100 is, and if this is where 100 is on my x-axis and my y-axis, then this is my room, right? And just like I explained in the video, this is like if we're looking down on the room from the ceiling, right? We're looking at the whole floor. So it's asking us to plot these 2 points, right? 10, 10 and 30, 30. So you know how to do this, right? 10, 10. There's a point. We can call that point A. And then 30, 30. It's going to be somewhere up here, right? And we can say that that's point B. So I'm just going to, for our reference, put point A and point B here, just so that we can look back at those and make sure they're good. Nashon, when you're ready for me to move on, just make a comment in the chat or text me that you've got this down and you're ready for us to move on to part B. And if you have any questions, you can ask me. I just don't want to be moving on until you're ready for me to move on, especially if you want to be like writing this down and keeping up. So yep, just let me know. Oh, part B? Perfect. Thank you, Nashon. Lovely. So when we're looking at the change in the x coordinate, what we're thinking about is when we went from A to B. Oh, goodness. I don't know what just happened there. When we went from A to B. Apparently, I can't use my green pen. That's fine. When we went from A to B here, how much did x change? So when my x values are the first one in my coordinate pair, right? So when I went from 10 to 30, how much did x change? That's also how big is this space in between point A and point B on our x-axis, right? This can mean lots of different things. And there are several ways that we can think about this. But the easiest way to see what is the change is just to do 30 minus 10, and we get 20. So that's the change in our x coordinate because we were looking at x, our x coordinate points, right? The part of the coordinate point that is the x value for point A and point B. Or we were looking at the x-axis, right? If this is 10 and this is 30, that means that the amount of space in between it is 20 units. Hopefully that makes sense. Think about it for a minute. And if you know how to do B, you can do C. So maybe try C on your own. And then you can put your answer in the chat. And if you get the correct answer, then we will move on to part D. While you're working on that, I'm going to as big of a deal. Okay, yeah. This should work for us. Hopefully I can use my... Yeah, Nashon, thank you for commenting that. Yep, it's 20 as well. And it's basically the same math, even though we're looking at the y coordinates. But since the numbers are the same, they're still 10 and 30. The answer to this one is 20 as well. Yep, it's exactly the same. Very, very good. Now, if these numbers were different, then your answer would be different. But since they're the same, it's going to be the same. Nice work. Okay, so what is the ratio of change in y to the change in x? Now, if you watched the video, the ratio of change is the same thing as the slope, right? And we know that the slope is the change in y over the change in x. And we already know what the change of y is. You told me that one. It's going to be 20, right? The change in x, that's this one. It's also going to be 20. And we know that if we're dividing something, right, 20 divided by 20, that's just 1 because it's something divided by itself, right? So 20 divided by 20 is 1. So our answer here, our ratio of change, right? Ratio, this can mean fraction. In high school mathematics, usually we look at ratios as fractions, right? So when we talk about the ratio of change, we're talking about the slope, which we put in the form of a fraction. The change in y over change in x, 20 over 20, which is 1. If you have any questions about that, go ahead, throw it in the chat. If it feels okay to you, if it feels good to you, we'll move on to part E. I have a song stuck in my head right now, and it's really, really hard for me not to hum it, but I know that's going to be really annoying if you're just listening to me humming, so I will refrain. Okay, awesome. So let's go ahead and look at part E. And this is talking about how far did the robot travel, right? So this is a distance problem. And when we're doing distance problems, we can either use the distance formula, which I did not show in the video, or we can use the Pythagorean theorem, which is where the distance formula comes from, which we're a little bit more familiar with. So I'm going to show you with the Pythagorean theorem, and if that's confusing to you, then I'll show you the distance formula and we can try it that way instead. Okay, so if we're thinking about this as the Pythagorean theorem, we're going to zoom in on our graph that we made up here, right? And we know that this distance here, the change in x, we know that that's 20, right? But we also know that this distance here, how much we changed going up and down in the y direction, is also 20. That's what that part C was asking us, that you gave me that answer, right? So if we know how much we went in the x direction, and then we know how much we went in the y direction, to find our diagonal direction, we can look at this as a right triangle, right? So our hypotenuse is our longest side, that's the diagonal side, and then our two legs are both 20. So if you remember the Pythagorean theorem, usually when we label our sides A and B for our two short legs, and then the hypotenuse, which is the long side, is C, right? So here we know that A is 20, we get that from the picture, and we also know that B is 20. So I'm going to have to jump away from this and hop back down to the other question. But if you were to need to pause me, go back a little bit, finish that up. Remember that I'll ask you before we move on to the next question. So if you need to pause it and look at that other picture, you certainly can. Okay. So how far did the robot travel between the 2 points? We're going to use the Pythagorean theorem, which is a squared plus b squared is equal to c squared, because we have a right triangle where we have 20 and 20 for our legs, and we're solving for c, which is the hypotenuse. So the first thing we're going to do is we're going to take our 20 and our 20, and we're going to plug them in for a and b, right? So we'll do 20 squared plus 20 squared is equal to c squared, which we don't know yet. Now, if we square these, if you were to put this into your calculator, and you can check me, if you want to take a pause, take a moment to check this math, you certainly can. 20 squared should be 400 plus another 400 is equal to c squared. So 400 plus 400 is 800 is equal to c squared. Now, some people look at this and they think, now I'm done. But we are not done yet. There is one more step that we have to do, because we can tell that 800 is way too big, right? 20 and 20, they're not long enough to make a triangle with 800 as the other side. They're just not close enough in number. They don't make sense. So what we're going to do is we notice that c has the square up here, right? It has an exponent of 2, and to get rid of that, we take the square root. We are also going to take the square root of the 800. Now, I don't know the square root of 800 off the top of my head. I know, a shame. I should be appalled as a math teacher. But I'm going to pull up my calculator on my phone and plug it in here. Square root of 800. Looks like it's 28.28. And this is a number that makes a lot more sense for our side, right? If I told you that I had a triangle where 2 of the sides were 20 units and 1 of the sides was 28.28 units, I feel like we would agree that that's reasonable, right? So I'm again going to pause here. Let me know when you're ready to move on to part F, or if you have any questions, either way. Awesome. Okay, so what was the speed of the robot? So here we have to use a formula, right? And the idea with the formula we use for speed is we're thinking about how much distance did we cover over an amount of time, right? If I told you I traveled 100 miles, it took me 5 hours to do it, right? If we wanted to express that as a speed, we would say, oh, you were traveling 20 miles per hour, right? If I take that whole 100 miles that I traveled, and then if I divide it by the amount of time it took me, then I get the speed that I was going at, right? Or my average speed. We call this an average velocity. And if you take physics, you focus a lot on this stuff. But here we're just going with the basics. So speed is equal to distance divided by time. So I take the length that I traveled, the distance, and I just divide that number by the amount of time that it took me. So the distance we already know. We know that that's the 28.28, right? That's the straight line that I traveled in to get from point A to point B. That's my distance. But what about my time? What's my time? So this question, we actually have to go back to the first question and the very initial information that they gave us. So before we even started solving anything, what did this question have to say? So it said the robot was at 10:10 at 1 second, and then at 30:30 at 6 seconds. So what that means is that the robot started at some point on the graph. We don't know what that point is yet. We're going to have to figure that out in a moment, actually. But the robot started out at some point, And then it traveled for a certain number of seconds, right? So at 1 second, it was at 10:10. And then by the time we got to 6 seconds, right? Because we don't know where it was when it was at 0 seconds, right? We don't know what happened in between 0 and 1 second. But by the time we got to 6 seconds, we were at point B, right? 6 seconds, we were at point B. At 1 second, we were at point A. So the amount of time that elapsed here is 5 seconds. 1, 2, 3, 4, 5 seconds, right? So we're going to take our 28.28 and we're going to divide that by 5. There we go. Divide it by 5. I'm doing this on my calculator, and it looks like I get 56 or 5.6. We can round up. So 5.66. And if we wanted to put units on this, right, I can't remember if we're in feet or not. I'm going to check back at our initial question. So here at the top, it says, yes, we're in feet. So this robot is traveling. Oh, we're just going to have to give this a second. Hopefully it will come back. Can I even draw? I can. Where did it go? What happened? Okay. Well, this is interesting. We were almost done, too. We were so close. Oh, it's coming back. It has returned. Oh, and then I messed it up. Oh, here it is. Okay. We found it. Good. So what I was saying before my computer went all wonky is that this 5.66 is in feet per second, because this was 28.28 feet. We divided that by seconds. So we would say the robot is moving 5.66 feet per second. Okay. So when you feel comfortable with that, you feel like you understand what we were doing there, we can move on to G. Okay, awesome. So this question is actually kind of tricky. And there are 2 ways we could do it. And both of them, one way is tricky algebraically, but has fewer steps. And the other way has an extra step, but I think that it's easier. So, what I would say is maybe we do the one with the extra step that I think is a little bit easier. And if for some reason it doesn't make sense to you, then we can switch to the other one. Okay. So this method depends on us noticing a relationship between the x values and the y values in our points. Right? This object is traveling along a straight line. So that means that if it's at 10:10 and it also goes to 30:30, that means that our x and our y values are always equal to each other. X is equal to y. So actually, we usually write that the other way around. So I'm going to write y is equal to x, because this falls into the form of y equals mx plus b, a little bit better than that. First value is also 10. If my y value is 30, my x value is also 30. Now, this series of questions didn't ask us to write an equation for x and y, but this equation is going to be really useful to us, because otherwise, if we want to figure out where the robot started, we're looking at our graph and we're saying, okay, we were at 10:10, and then we went to 30:30, and we did this between 1 second and 5 seconds. but where was our 0 seconds place, right? So the tricky thing about this is with the information we currently have and with the speed we currently have, that 5.66 feet per second, that's in that diagonal direction, right? So if we wanted to go backwards, we would have to go backwards in that diagonal direction. And that would be tricky. That's all I'll say, is it's tricky. So what we're going to do instead is we're going to find what is the speed in just one direction, right? So instead of this diagonal speed, right, how fast are we moving in the x direction? Okay, and the way we figure that out is we're going to take the distance that we changed in the x direction, and we know that this distance that we changed in the x direction is 20, right? This speed in the x direction is still going to be distance over time. We just have to remember that this is not the total speed, it's just the speed in the x direction. So I'm just going to do an, and we already know is 20. And the amount of time it takes us to do that, we already know is 5 seconds, right? So we're going 20 feet in 5 seconds, and this is actually really great for us, right? Because it comes out really evenly. So that means we are traveling 4 feet per second. So every second that we're traveling, we're going 4 feet in the x direction. So when we're looking at where our robot is, right? Here at point A, we were at 1 second. And here at point B, we were at 5 seconds. But where were we when we were at 0 seconds? Well, to answer that question, we know that between, on our timeline here, right? If we look at 0, 1, 2, 3, 4, right? This is our total timeline. Here we have point A. Here we have point B. In point A, we were at 10 feet. Point B, we were at 30 feet. If I go backwards a second, right? I'm going back to new point, I don't want it to be like A, B, or C. Nashon, I'm going to use an N for you. Okay, so if we're going back to that beginning spot, if we're going back to point N, we're just going to go back 4 feet because we're only going back 1 second, right? We're going back 1 second to second 0. So if I go back 4 feet, I get 6 feet in the x direction. And I know from that equation that I pointed out earlier that in this case, y is equal to x. So if x is 6, that means that y is also 6. This is a really tricky question because it's not something that I've overtly went over in the video. It was really in here to be a little bit of an extension, a challenge. We were hoping to see some people stretch themselves and get there. But if this one feels harder than the other ones, that makes sense to us. Okay, so if you have any questions, let me know. If you feel comfortable with this, if you feel like you understand what I did, also let me know that. And we can see, I don't know if you want to do part 2 on this one together. It's very similar to part 1. It has some more difficult questions. If you want to do part 2 together, we can do that. Or if you would like to go to a different worksheet, we can do that too. So it's totally up to you, Nashon. Okay, good. So it looks like we understood G, which is good. So just whichever section you'd like for us to do next, just let me know and we can do that. And if you're also feeling like, you know what, Miss Wesneski, I just did an entire page of math. It is a Saturday. And if you're ready to take a break, that's okay too. Do part 2? Perfect. Awesome. Okay, so looking at part 2. Part 2 feels very similar, but we can see that the numbers are a little bit different. So we know that, this is going to be a little bit of a different question because it doesn't break it down quite as much for us. We have to do a little bit more of the thinking on our own. So here it says your mother received a robot vacuum cleaner, ooh, fancy, as a gift and wants you to help her program it to clean a vacant 30-foot by 30-foot room. The vacuum is at position 12:9 at time t equals 2 and is at position 24:18 at t equals 5. Answer the following question. How far did the robot travel over 3 seconds? Okay, so let's draw a picture first. Even though it doesn't ask us to draw a picture, the smartest thing we can do in this situation is draw it out so that we can see what's going on. If we can't see what's going on, we really have no hope of solving this correctly. Okay, so I'm going to make a graph here, x and y. And this is going to go from 0 to 30 because we know that our room is 30 foot by 30 foot. Okay. So if I wanted to plot my points, I'm going to make this first point, which is 12:9. I'm going to make that point A. So 12 would be about here, 9 would be like there. So I'm going to say that this is point A. And then I'll make the 24:18 point B. 24:18. That point B. I want to make that little timeline that I was using earlier because I think that that's pretty helpful in this situation. So we know that the robot starts moving at 0 seconds. 1, 2, 3, 4, 5 seconds. And we know that point B is over here at 5 seconds. And we know that point A is at 2 seconds. So when this question asks us, sorry, the motorcycle just went down my street, so sorry if that was loud for you. But so point B is at 5 seconds, point A is at 2 seconds. So when this says, how far did the robot travel over 3 seconds? It means in the 3 seconds between point A and point B, 1, 2, 3 seconds, how far did the robot travel? Okay, so what this means for us is it's asking, what is this diagonal distance, right? How far is it between point A and point B? And for us, that's going to involve us, again, using the Pythagorean theorem, right? So if I make this into a triangle, how much did I change in the x direction? How much did I change in the y direction? And then what's my distance going to be? So if you remember from before, to figure out how far we changed in the x direction, we're going to take where B is, which is at 24, and we're going to subtract where A is, which is at 12, right? So if I wanted to figure out my change in x, hey Abdel, how are you? And my change in y. Abdel, right now we're working on day 11. And we're doing part 2. So if you would like to follow along with that, you certainly can. If you have questions about another assignment, just let me finish up this one with Naishan, and then I can help you with whatever assignment you need help with. Naishan, you just commented 4 seconds. Did I make a mistake someplace? Oh, goodness. Sorry, my computer just went wonky again. We're just going to undo whatever that thing was that just happened. Oh, goodness. Yeah. Abdel, you might not have seen this happen before, but Naishan is very used to my computer doing terrible things and messing me up. All right. So, Naishan, it's kind of, when we're looking in between, like, I don't know if this is what you meant, because 4 seconds is a really kind of vague comment, right? But here between the 2 seconds and the 5 seconds it's just 3 seconds. So we don't count the 2 when we're counting, right? We count the number of jumps, right? How many? Oh, perfect. You got it. We're good. Yay. We're good. Perfect. All right. So the change in X in between the 24 and the 12, the way we figure out what that change is the same way that we figured out that change before, right? So in part 1, we had like our X values were 30 and 10. And the way we figured out the change was we subtracted, right? And we got 20. So here we're going to do the same thing. We're going to take our 24 and we're going to subtract our 12. And our answer should be 12. Either Naishan or Abdel, whoever gets to it first, go ahead and find the change in Y, which is the, our Y values are 9 and 18. So figure out the change in Y, and then we will be able to plug into the Pythagorean theorem. Hoping that we would be back to school at least in like June, but since that's not going to happen, if I don't end up talking to you guys before the end of the school year, I certainly hope that I will, but I hope that you both have a good summer and all of that as well. Oh, crazy times we live in. Crazy times. And Naishan, if you have any questions about what I asked, or if you don't understand what I asked, just let me know and we can go over it. Oh, thanks. Will I be teaching 11th grade? I don't know what I will be teaching next year. They haven't officially told us. Now, when they asked us for our preferences, I did say that I would like to teach geometry again because I really enjoyed teaching geometry. I think the main person who teaches 11th grade math, which is Algebra 2, is Mr. Kanda, and he is awesome. And Abdel, I think that you will really like him if you end up having him. The other Algebra 2 teacher this year, I think we had a long-term sub because I don't think they filled the position at the beginning of the year. They couldn't find somebody. Hopefully they will have someone by next year, but it looks like we might have some leeway on time because we might, we don't know what the beginning of next year will look like, right? We don't know if we'll be in person or if we'll be at home. So tentatively, as it stands now, it seems that I'll probably be teaching geometry again, but we don't really know. Okay, Naishan, don't know how to find Y. That's totally okay. We just have to think about the fact that we're doing the same thing where we're finding the change, right? And when we see how much did we change, we're going to subtract. So our two Y values are 18 and 9, right? So we're just going to subtract 18 minus 9. Thanks, Abdel. I'd love to keep having you guys too, because I do, the fact that we haven't gotten to finish out this year is really sad, for sure. And I mean, that is something that they could consider doing, leaving us with giving us the same students again next year, especially if we start with virtual learning at the beginning of the year. But Nation, when you have a chance, just let me know whether this part I did in red made sense. The finding y part. Does that make sense to you? Okay. Oh. And now that we know our change in x, which we know was 12, and our change in y, which was 9, now that we know that those two distances, we can find c using the Pythagorean theorem, right? Pythagorean theorem. I'm going to do this part in green, and I'm going to zoom in a little bit over here, try to write a little bit smaller. A squared plus b squared is equal to c squared. Great, Nation. Thank you for letting me know. So a squared, that's going to be our change in x, right? So it's going to be 12 squared plus our change in y, which is, oh, I almost did it in my head. See, I was thinking 9 squared, and then I almost wrote 81 instead of writing 9 squared, because I'm really on my game today, is equal to c squared. Okay, so 12 squared, you can put this in your calculator, or if you have this memorized, also perfect. That's going to be 144 plus 9 squared is 81 is equal to c squared. Now, if we add those together, this is me just doing it in my head, but I think it's 225 is equal to c squared. I'm going to double check that on my calculator just to make sure I'm not leading y'all astray. So this did 144 plus 81, 225. Brilliant. Okay. So again, this is where a lot of us think, oh, we're done. We got an answer. But actually, we haven't gotten an answer, right? Because we have to take the square root. 225 is much too big to make a triangle with 12 and 9. So square root. The square root of 225, I believe, is 15. But also, I will be very embarrassed if that is wrong. And I will swear you both to secrecy. Yep, it is 15. Okay, everything's all right. So that means that c is 15, right? So 15 is equal to c. Sorry that I'm like writing over myself here. That's a terrible teacher thing to do. We're going to let the computer breathe for a minute. It's saying it needs a rest. And we're back. Okay. Perfect. No. Okay, there we go. Okay. So we got C for our answer. We got 15 for our answer after using the Pythagorean theorem right here in this green section, right? So our answer was 15 is equal to C. And that's actually the answer for this question, right? Sometimes we get kind of bogged down in all of the steps that we're doing, but this question was asking how far did the robot travel over 3 seconds, which for us was 15, okay? So if the answer to the question, how far did the robot travel, is 15 feet. The way we found that was we plotted our points. We figured out that the change in x and the change in y were 12 and 9. And then we used those answers to do the Pythagorean theorem. All right. Nation, when you feel comfortable with this and you are ready to move on, you let me know in the chat. And Abdel, if you're seeing any of this stuff and you have a question, please chime in. I would love to answer. Perfect. Thanks, Nishan. All right. So this is asking us for the constant speed of the robot. So all we have to do is remember that speed is equal to the distance we travel over the time that it takes us to travel. Okay. So we're going to take the distance we went and we're going to divide that by the time. So I'm going to give you a moment, Nishan. Give you a moment, take the distance we traveled and divide that by the time it took us to travel. And if you need me to elaborate, let me know. Nishan, did what I asked make sense? Yes, exactly. You got it. So 15 feet over 3 seconds is 15 divided by 3, which is 5 feet per second. Perfect. Perfect. So C is asking us, what is the ratio of change in the x coordinate to the y coordinate? So again, this is the same thing as slope, right? And we did this in the last question where we were doing the change in y over the change in x. So you can go ahead here as well and just plug in the numbers for what we got for x and y. And you can give this to me as a fraction, or if you want to put it in your calculator and give me a decimal, either way is fine with me. I've still got that song stuck in my head, Nishan. It's actually from Beetlejuice, the musical, which is not something I ever thought I would say out loud. But there's a song where Beetlejuice, who in the musical is like this I guess he's technically like a demon in the musical, but he's functioning sort of as a ghost. And he's trying to get this girl to say his name 3 times in a row so that he can like come to life. And it's very entertaining to me. You are so close to being right. So Nahshon, you did something that I was worried we were going to do, but that's okay. We can fix it. So 12 over 9, that's actually the change in x over the change in y, right? But that's actually a little bit backwards to what we want. We want the change in y, which here we had the change in y, right, was 9. So that means we're going to do 9 up top because it's the change in y. And then the change in x was actually 12, right? So that 12 is going to go in the bottom. And if we do that division, 9 over 12, I believe, is 0.75. I think it goes to 3/4. So we could either express this as 0.75 or 3 over 4, either way. Let me know if that makes sense or if I just confused you. If I confused you, let me know and I will do better. Perfect. Beautiful. Okay. I keep trying just to scroll down a little bit and it just doesn't want me to. Okay, there we go. All right, so when we look down here, where did the robot start? Okay, where did the robot start? So this is very similar to the last question before. And if you remember on the last question, we made an equation between x and y that was like, oh, x in terms of y is this, right? And that made it a lot easier for us because we realized that x and y were exactly the same. Now, in this case, that's not quite true. Our equation for x and y, and I'm just going to give us this part because it's not really what we're trying to focus on in this question. Our equation between x and y is actually having to do with this ratio of change that we just came up with. So our equation between x and y is that, I just want to check my numbers and make sure that I'm not getting myself confused. Yes. Okay, is that y is 3/4 of x. Or you could also say that y is equal to 0.75 times x. Either way. And having this equation lets us know, like, if we can figure out what the x value is, then we can also figure out the y value. And this is a lot easier than finding than using the Pythagorean theorem and working backwards, because that algebra is much more intense. Okay, so when I'm looking here, x direction, and we're still going to do distance over time. Now our time is still the same, right? We're still using that 3 seconds. But the distance is different because here we're only looking at the distance we went in the x direction, right? And we know that in the x direction, we went a total of 12 units in those 3 seconds. So here we're going to do 12 divided by 3, distance divided by time. And we end up getting 4 feet per second, which is actually the same speed in the x direction as we found last time, which is kind of funny. It won't always work out that way, right? So this step is a little bit different than last time, right? Because if we want to know where the robot started, what that's really asking us is where was the robot when our time was equal to 0 seconds, right? So right when I hit my stopwatch and I decided to let the robot start moving, what was the location of that robot? Okay, so when we look up here at the timeline that we made, right, with our A and B, I'm going to make this the same point N as our starting point as last time, right? Here, instead of being 1 second away from point N, point A is 2 seconds away, right? So instead of moving over 1 second, which would be 4 feet, right, we're going to go 2 seconds. So if each second we're moving 4 feet, then in the first second we're going to move 4 feet. In the second we're going to move 8 feet. So this means that we moved 8 feet in the X direction before we got to point A. Oh, I forgot that. Yeah. So before point A, we moved 8 feet in the X direction. Now, if that's the case, all we have to do is take point A, rewind it 8 feet, right? And then plug our X into our equation so that we can get the Y value. Okay, so let's look up here. Our initial X value was at 12.9, or our initial value in general was 12.9. Our initial X was at 12. So we're looking for 8 feet before that 12. So we're going to do 12 minus 8, and we get 4. So for point N, our initial X value is 4. That's where we started in X. And to figure out where we started in Y, all we're going to do is we're going to take our 4 for X. Right, this was X. We're going to take that 4 and we're going to plug it into our equation. So Y is equal to 0.75 times 4. And you can check this in your calculator if you'd like to, but we should get that Y is equal to 3. So N is 4.3 should be our final answer. Let me know and I'll answer them before we move on. And just a heads up, Nation, once we finish this part 2, I am going to have to stop our coach class today. I was only planning on going until 3 o'clock. I'm absolutely fine extending that since we're in the middle of a question. But once we're done with this one, I think we're probably going to be done for the day. But I do also have coach class on Monday at 2 o'clock at the DHHS live session. So if you would like to log on to that, we can also help you out there. Oh. Okay, this computer is being very frustrating. Okay, cool. So let's take a look at part E, which says, where will the robot be at t equals 3 seconds? Explain how you know. And here I'm going to make our timeline again, right? And then we can talk about how to figure out where we'll be at t equals 3 seconds. So on our timeline goes from 0 to 5. 1, 2, 3, 4, right? We know we had point A here, which was at 12.9. And then we have point B here, which was at 24.18. And then we also had our point N right here, which was at 4.3, and that's where we started, right? Now I'm going to make a point C, which is at 3 seconds. And we want to figure out where is that point C. Now, what we did when we figured out the starting point, where we said, okay, we're going to go backwards from A, and we're going to go backwards from A 2 seconds, which is the same as 8 feet. We're going to do exactly the same thing here, but instead of going backwards from A to N, we're going to go forwards 1 second to C, right? So if we're going forwards 1 second in the X direction, we know that we're moving 4 feet per second, right? We figured out that our speed in the X direction was 4 feet per second. So that means that in the X direction, we're going to add 4 feet, right? Because we're going 4 feet further in the X direction. So for point C, first we're going to take our 12 and we're going to add our 4 feet. We get 16. And then we have to figure out what is our Y value. Right? Now we could also find the speed in the Y direction, and we could do the same thing where we're adding that speed on or taking it away. But what we could also do is just plug into that equation that I mentioned up here, right? I also wrote it as Y is equal to 0.75x, and we can just plug this X value, which is 16, in there, right? So if we get Y is equal to 0.75 times 16, now if I take that 16, I multiply it by 0.75. You can check me again if you would like to, but I believe that this is 12. So that means that our final point is going to be 16, 12. You can let me know if that makes sense or if you have any questions. Cool. Awesome. All right. So looking at this next one, we're going to approach this in an interesting way. Hopefully you'll be able to follow. If for some reason what I'm doing is like super not cool with you, let me know and I will change course and switch our tactics. Okay, so if I'm looking here at my picture, right, I talked about the fact that this wall is at 30 and this wall is at 30, right? Because we're looking at a 30 by 30 room. Now, the important thing about this is that we know that the X number has always been higher than our Y number, right? 16 is higher than 12. 4 is higher than 3, right? 12 is higher than 9. 24 is higher than 18. So what that means is we are going to reach 30 on the X wall before we were to reach 30 on the Y wall, right? So that means that we are going to hit the side wall. We're not going to hit the top because we're moving faster towards that side wall, not towards the wall that's parallel or perpendicular to the Y-axis, right? So we're not going to hit this top one, the Y one. We're going to hit the X wall. So we want to figure out what is this point, right? And that's where, again, our equation really comes in handy because our equation says Y is equal to 0.75x And when we hit the wall, we know what the x value is, right? We don't know what the y value is, but we know that if we have hit the wall, we are at 30 feet, right? Because this whole wall here is at 30 feet. So what we can do is we can just plug in our 30 feet for x, and we can get y is equal to 0.75 times 30. Now this one I can't do in my head because 30 is not divisible by 4. So it's not going to be nice. We're going to have a decimal here. Let's do, so 30 divided by 4 times 3, or you could just do times 0.75, whatever's faster for you. And I get 22.5. So that means that the location where we hit the wall, that question mark right there, I'll just leave that as my notation. That's going to be 30 for x and 22.5 for y. Okay. So it looks like G will be our last question. Oh, exciting. Perfect. All right, last one. So how long does it take for us to get to 30 and then 22.5? Right, that's the question that they're asking us. What time will it be by the time we get there? And I think that the easiest way to answer this is, again, just to look at our speed in the x direction instead of our diagonal speed, right? So we know that our speed in the x direction is 4 feet per second. What just happened? Okay, well, that's frustrating. Just give me like a moment. Okay. Okay, I'm not going to mess with it anymore. So our speed in the x direction is 4 feet per second, right? And we know that at 0 seconds, because let's just go with 0, that'll give us a time to where we don't have to account for the fact that we didn't start at 0. So at 0 seconds, we were at 4.3, right? And at whatever our mystery number of seconds will be, right? When we hit the wall, we're at 3022.5. I'm going to label this W for wall. Hopefully that's not too confusing. So how far did we travel in the x direction in total from the time that we started to when we hit the wall? Well, that's just going to be 30 minus 4, which is 26 total, right? So our distance is 30 minus 4, because we're just looking in the x direction, right? Our distance in the x direction is 30 minus 4, which is 26 feet. So we can plug our speed and our distance into our formula that we have for speed, right? So to figure out the time, because the formula we have for speed involves speed is distance over time, right? So if we have to solve for time and we have speed and distance, we can use this formula because we have 2 out of the 3 variables. So if we take our speed, which we know is 4, and then we take our distance, which is 26. I'm going to zoom in here, scroll up a little bit. Okay, so we have to solve this formula, right? Where we have 4 is equal to 26 over time. And hopefully, Naishan, you especially should remember this because I remember we did a lot of it and you were pretty good at it when we were doing trig functions. We did a lot of this kind of stuff where we saw something equal to a fraction, and to make it easier to solve that, what we would do is we would turn our number into a fraction, right? So we have this whole number here, 4. We can turn that into a fraction by saying 4 over 1 because dividing by 1 doesn't change anything. And then all we have to do is cross multiply here, right? So when we cross multiply, again, hopefully you remember this, we take the top of one of our fractions and we multiply it by the denominator of the other fraction. So numerator of this first one, which is 4, times the denominator of the other one, which is t. That's going to be equal to 26 is the top of our second fraction times 1. We could do 26 times 1, but we know that that's just 26. Oh, my eraser's not working. Oh, now it's working. Okay. Yep. So now to solve this for t, the last thing we have to do is just divide by 4, and we should get our time, right? So 26 divided by 4, if I'm trying to do this in my head, I'm pretty sure that it's 6.5. I'm going to check this on my phone though. You can also check my division and make sure it works. And then just let me know if you have any questions about this last question or not. And if you're feeling good about it, we can count this as a win of a day. I can give you your bonus point for coming to live coach class. And then we can say, see you here same time next week. And as soon as we finish up this live stream, I can listen to the song that's been stuck in my head. Get it out. It's a good time. All right. Oh, right. I'm supposed to be checking this division. I wasn't doing that. 26 divided by 4 is 6.5. Yep. Okay, so Naishan, we feel good about this. You're okay to submit it, all that stuff. Okay, so I'm not really sure how long the lag time is on this right now. I feel like we're probably at a pretty good place to stop for today. So Nishant, I really do want to say thank you to you for giving up part of your Saturday to come work on this with me. You've done a really nice job, and I'm super proud of all you've accomplished. I'm actually going to leave this coach class up on the YouTube channel. So if you need to come back and reference it or find any of your questions again, you can go ahead and do that. It should be up at least for the next couple weeks. And yeah, if you have any questions at all, you can feel free, reach out by text, call, email, whatever you need to do, and we will get you all squared away. All right. So thank you so much, and enjoy the rest of your day and the rest of your weekend. And yeah, have a happy Saturday.